So graph y equals x squared. What's x squared look like? Parabola, U-shape. Where's the vertex? 0, 0. And then this is the parent function, so we should already know like 1, 1, negative 1, 1, or 2, 4, or 3, 9. Oops, that's not 3, 9. 3, 9. And then the mirror points. Okay, and then we covered this in chapter 1, talking about inverses and discussing if the inverses were functions or not. So my question would be, if we find the inverse of this, would it also be a function? Why not? Why can't? Right, so if we find the inverse of this one, it's going to be a parabola that opens that way. And then if we do a vertical line test, it fails. So what we were doing to make this have an inverse that was also a function is we maybe only chose part of this. We put a domain restriction on this, and it looks something like y equals x squared, and then we had x greater than or equal to 0. That was one example. That wasn't the only one we did, but that was one example. So if I had that, then it would just be the positives and 0, x values. It would just be this part of the parabola. And then if I'm going to do the inverse of that parabola, without even finding the equation, if I'm going to do the inverse of that parabola, how do I do it? Without even finding the equation. Yeah?
Switch the x and y.
Okay, so 0, 0, I'll switch that. Yep, 0, 0. 1, 1, let's switch that. 1, 1. 2, 4. 4, 2. And 3, 9. 9, 3. And now we have this graph. Does anybody know the equation of that graph? Square root of x, y equals square root of x. And would this be the positive square root of x or the negative square root of x? Positive. If it were the negative, then we would have had to use x is less than or equal to 0 for the parabola. So now these are inverses, and is this pink inverse, is that a function? And the green one, is that a function? So this would be a function that has an inverse that's also a function. So we've talked about this before, having domain restrictions, so that we have an inverse when we we have a function for the inverse. Now, what we have not done yet is we have not graphed sine or cosine. Typically, we should do it next, but with the quarter ending, by the way, next week, week from Friday, it's the end of the quarter. Yeah, already. And we are not doing quarter exams. But what we are going to do, though, is we are going to have a test before the end of the quarter so that your chapter 1 test isn't the only test you've had this entire quarter. So what I'm doing is I'm cutting this chapter into different parts, and we'll do a test over 4.1 to 4.4 plus 4.7, which we're doing today. And then we'll start graphing, and we'll have a test over graphing second quarter. Okay, so you will do graphing. We're actually going to do it next week, and you should have done graphing last year. You don't actually have to know how to graph this to do what we're doing today, but they're using the graph to explain why we're doing what we're doing today. Okay? So this graph is the graph of sine x. If I were going to talk about the inverse of sine x, would the inverse of this graph be a function? Do you want to see the inverse? There it is. Would the inverse of this graph be a function? It would not, because it would not pass the vertical line test. So because it's periodic, it like repeats itself over and over again, because this does not have an inverse that is a function, what they did was they put a domain restriction so that we will have a function when we do the inverse. So the domain restriction for sine, if you're looking at the graph of sine, they chose just one part of it. And in this one part, we have negative and positive values. We have negative y's and positive y's, and we also have 0. It has every single possibility that you would have for sine. And it's hard to tell exactly what we're counting by here, and since we haven't reviewed graphing yet, this is 0, this is pi. What's halfway between them? Pi over 2. And then this is negative pi. What's this one going to be? It's negative pi over 2. Okay? So they, as in people who decided what math was going to be a long time ago, decided this is the restriction for sine. Negative pi over 2 to positive pi over 2. I'm going to take that, and since we haven't graphed it, I'm going to put it on a, like a unit circle, so you can see what it looks like on a unit circle. Yeah? Let me say my name. Okay, hearing things. So negative 2 to positive pi over 2, I should move this around. Get that out of the way. Okay, negative 2 to positive pi over 2 is these two quadrants, quadrant 1 and quadrant 4. But in quadrant 4, we're talking negative angles, not counterclockwise. We're talking clockwise in quadrant 4. So that's kind of like different than what we've been doing, which is why people make silly mistakes on this section, because they want to revert back to what we've already been doing. But this is new. This is different. So now the same thing is with cosine. Cosine is periodic. It repeats itself over and over again. So they took a chunk and they said that the domain restriction for cosine, so that we have an inverse that is also a function, is going to be from 0 to pi. That was so ugly. I'm so sorry. Okay, so cosine inverse is going to be from 0 to pi. Sine inverse is going to be from negative pi over 2 to positive pi over 2. Okay so far? Okay. Then we've got tangent and cotangent. Oh, and by the way, I'm sorry, I didn't even say this, but it says it there. Cosecant and sine have the exact same domain restrictions, and cosine and secant have the exact same domain restrictions. However, tangent and cotangent do not have the same domain restrictions. So tangent, remember when I find tangent, I do something over something. What do I do when I find tangent? Tangent, y over x, right? Tangent is going to have, and I'm trying to color code all this, and then I'm not doing it. Tangent is y over x. So tangent is going to be the same as the sine inverse. So tangent is y over x. It's going to have the same domain restrictions as sine inverse, which is negative pi over 2 to pi over 2. And then cotangent is what over what? X over y. So cotangent, the domain restrictions are the same as cosine, which is x. Inverse. So your only choices for domain restrictions, either 0 to pi or negative pi over 2 to pi over 2, you just have to know which ones they are. The top of this page, we are actually not going to graph the inverses. But looking at the inverses, the only thing that you need to know here is instead of writing y equals sine inverse, they actually wrote it a different way. They wrote arcsine. That means the exact same thing as sine inverse. Arcsine is the same as sine inverse. It's just how they would write it if we were graphing it as a function. So arc cosine means what? Cosine inverse, and arctan means tangent inverse. You don't have to know the graphs, but all of their domains and their ranges, same as the sine to switch. Okay, so what we're going to do is we're going to find the exact value without a calculator, and all of these are going to be in radians. All of our answers, any angles are going to be in radians. We're not going to do degrees. However, I do like to think of things in degrees. I'm going to put all my final answers in radians. And I'm going to model exactly the best way of doing these so you don't make a bunch of silly mistakes. Ready? Okay. Sine inverse 1/2. Sine inverse means what angle is sine 1/2? That's what sine inverse means. Remember we were doing inverse on our calculator and we were doing inverse. Remember that? Do you already know it's 30? Okay, but here's the thing. Sine has domain restrictions. The domain restrictions are negative pi over 2 to pi over 2. 1/2 is positive. So out of my two quadrants, that will be just the first quadrant. It would normally be first and second, but that's not in our restriction. So here's where theta is. And somebody yelled at, that's 30 degrees. Good job, you were smart. But we're going to write our answer as radian. 5 or 6. And that's it, yes. B, cosine, negative, radical 3 over 2. So I'm going to think cosine's restrictions first. Go from 0 to pi. Second thing I'm going to think of is this is a negative. So where is cosine negative? It's quadrant 2, not drawn to scale. Next thing I'm going to think of is what reference angle is cosine radical 3 over 2? I know it's a 30, 60, 90, and sine of 30 is a half. Where is cosine radical 3 over 2? You all hear yourselves, everybody's yelling 60 and 30 at the same time. Should this be something we know? Yeah. You want this to not take all day, you have to know these values. The answer is 30. It is 30. So that's a pi over 6. Well, pi over 6 is not my answer. Because I need to know in the second quadrant, if I start at 0 and I rotate counterclockwise, then I have pi over 6 left. What's the actual angle? 5 pi over 6. Kind of the same questions we were asked before, except for now we have, we're only finding one answer instead of two answers. Okay. Tangent, negative 1. So I think tangent is y over x. So that means tangent is going to have the same restrictions as the y, as the sine. Negative pi over 2 to pi over 2. This is a negative number. Which quadrant out of 1 and 4 is tangent negative? 4. Now I need to know what reference angle gives us a 1 or a negative 1 for tangent. 45, which is a pi over 4. But to get there, we're not doing all the way around. We're starting at 0 and we're going clockwise. So what's the answer for this one? What do you think? So it's not 7 pi over 4. It is negative pi over 4 because in this instance, when we're doing inverse functions, we have to use negative pi over 2 to positive pi over 2. So this is going to be negative pi over 4. It is coterminal with 7 pi over 4, but that doesn't fit in the restrictions. Okay, and then we have secant inverse, radical 2. So secant is the same as cosine 0 to pi. That's positive, so first quadrant. And really fast, what triangle is going to be with radical 2? It's got to be 45. Really fast, then what's this angle? Pi over 4. Save yourself some time, know those values so that you can do 100 of these for homework. Not 100, but a lot. Okay, next. Arc cosine. What's that mean? It means cosine inverse -1. So it's the exact same question. If you see arc, it's the exact same thing. Where is cosine -1? So my cosine restrictions go from 0 to pi. Where's cosine 1 or -1? Cosine is at, where's that 1 or -1? At pi. Answer. Because remember, pi is the ordered pair -1, 0. And cosine's -1 there. Cosine's there. Arc cosecant 2. So cosecant is sine -pi/2 to +pi/2. This is positive, first quadrant. Do you have this one memorized, or do we need to change it to sine? Change it to sine? You have that one memorized? 30, okay. But it's not 30 degrees. What is it? Pi over 6, yeah. The tangent and the cotangents, people seem to memorize those last. Cotangent is the same thing as the x over y, so I'm using the restrictions of 0 to pi. This is negative, so that's going to be in the second quadrant. I need to know when cotangent is radical 3. And here's a hint, it's either 30 or 60. See that? 50-50 shot, right? It is 30, yeah. 30. So if that's 30, that's pi over 6, but I need my answer to be in the second quadrant by pi over 6. Do you have a special way that you've memorized that that one was radical 3?
I used that the one was smaller.
Oh, you're thinking that way?
I'm just thinking it was a triangle.
Gotcha. Okay. So my silly method, not all that helpful, but a little bit helpful. I have this one memorized. I have this one memorized because 30 degrees is the one with all the 30s. So that means the tangent of 60 is the one with just the 1 30. I don't know. The one with 30 is the one with all the 30s. That's what I say in my head. So then when you flip them, they switch. So if I flip and I do cotangent 30, that's the one that's radical 3. But I have this one memorized. All right, one more. Arc sine. So that's sine inverse. So we're doing negative pi over 2 to pi over 2. Negative is in the fourth quadrant. I need to know when sine is radical 3 over 2. I know it's not 30 degrees. 60 degrees. So that is what angle pi over 3, but our answer has to go negative pi over 3. Okay. Now, that was so easy. Let's add on more. These are composite questions, and these do not need to be hard. Just like take them step by step. See, we always do what's on the inside first. So when I look on the inside, do you see how that just says cosine? That does not say cosine inverse. That just says cosine. So that means go to pi and tell me cosine at that location. Go to pi, and what is cosine at pi? -1. So I just answered the part in the center, in the inside. See how it covered up the other part? I don't want to look at it. Now I'm going to bring down that other part. Sine inverse. So my next question is, where is sine inverse -1? So remember, sine has to be from -pi/2 to pi/2. If we're doing angles, there's a restriction. If I'm finding angles, there's a restriction. So where is sine -1? -pi/2. There's 2 questions in one. So the next one, tangent 3pi/4. I'm going to cover up that outside part because I don't want to look at it. Tangent 3pi/4. They're giving me an angle, so I'm going to immediately go find that angle. 3pi/4. That's in the second quadrant. 3pi/4. That's a 45-degree reference. What is the tangent in the second quadrant and of 45 degrees? Tangent. Tangent is y over x. This is a 45, 45, 90. Well, it's 1, but in the second quadrant, it's -1. So then, now I bring that down. Now my new question is arc cosine -1. So if we see arc cosine, we're finding an angle, we have to have those restrictions, 0 to pi. Where is cosine -1? Okay, pi. So if you're doing inverse or you're doing arc, you're finding an angle. If there isn't an inverse, then you're just like going to that angle and finding the answer. So again, example 3. Now I'm covering up the stuff that's on the outside, and I'm just doing cosine inverse -3/2. So if I see inverse, that's a restriction, and that's me finding the angle. So cosine is 0 to pi. Cosine is negative in the second quadrant. Where is it √3/2? 30 degrees, which is pi/6. But I want to know the second quadrant angle, so 5 pi/6. All right, so I have that answer. Then I can take my finger away and say, I need to know the tangent at that location. So in the second quadrant, tangent is negative. In the second quadrant, 5 pi/6, which is a pi/6, which is a 30-degree reference angle, tangent is what of 30 degrees? Tangent of 30 degrees is? Okay, so negative √3/3. Tangent of 30 is the one without the 30s. Do you see how these were kind of different? They're kind of opposite. All right, so this one, example 4, I'm going to cover up and draw a picture. Cosecant is the same as sine, so we have a restriction. And then I need to know where cosine is negative. That's the fourth quadrant. And where is it? Cosecant is 2. It's a 30-degree, which is a pi/6. But to get there, it's negative pi/6. And we bring down sine. Now I want to know the sine at negative pi/6. Is it positive 1/2? No, in the fourth quadrant, it's going to be negative 1/2. And I forgot to write the negative. There we go. Okay, the next one. It says watch out because some of them are tricky. If you guys see arc sine and you see sine, that's the same thing as like sine inverse of sine. And typically, what do inverse functions and the actual function do? Cancel each other out. So you would probably, by intuition, think the answer is -3 pi/4. But it's not. So let's look. One step at a time. Ignore that outside part. Sine. -3 pi/4 is in the third quadrant. We're going negative. It's in the third quadrant. It's a pi/4 in the third quadrant. Sine is positive or negative there? Negative, and then what is sine at any pi over 4? That's 45 degrees, but what's sine? Radical 2 over 2. So negative radical 2 over 2. And now I'm going to bring down, and it says, now let's do arc sine or sine inverse. But anytime you do arc sine or you do sine inverse, there's a restriction. Negative pi over 2 to positive pi over 2. So the question is, where is sine negative, fourth quadrant, and pi radical 2 over 2? What? Pi over 4, but in the fourth quadrant, when we have this restriction, it's going to go clockwise, so negative pi over 4. You see how that did not completely undo itself? That would be like the tricky ones. I'm going to skip 6 to make sure we get through some of the others. Number 7. We ignore that cosine. We look on the inside. Sine inverse. If we're doing inverse, do we need restrictions? Yes. 0, or not 0. Negative pi over 2 to pi over 2. So where is sine 3/5? Is that one of our special ones? It's not a special one. But we can still answer this, because I actually don't even need to know the exact angle where it is. I just have to know where it is. So what, is this going to be the first or second quadrant? And remember, sine is y over r. So my sine value, my y value is going to be 3, and my radius will be 5. So that's where it is. I don't need to know the angle because now I have another step that says find cosine at that same theta. So whatever the angle was, it doesn't matter. I need to find cosine of the exact same triangle. You know it? It is. And where'd you get that 4 from? It's a triple. So the cosine of that theta is 4/5. I think that wasn't hard. Let's do another one of those. Ignoring what's out there. Cosine inverse. So that means restrictions. Cosine 0 to pi. Cosine inverse of negative 5/7. That tells me which quadrant. Second. So there's theta. Also, cosine is x over r. So my x has to be negative 5, and my r has to be 7. How do I know the x is negative and not the r? R can never be negative. That's fine. And yes, also because it goes to the left, so it has to be negative. But r is never negative. Now we have to find tangent. So tangent is, we're going to find tangent of that same theta, whatever it is. Tangent is y over x. So I don't know y. How do I find y? Is it a triple? It's not. How do I find y? Pythagorean theorem. So y squared plus negative 5 squared equals 7 squared. And I get square root of 24, but we always want to check when we get square roots if they can be simplified. Square root of 24 is 4 times 6. So 2 square root 6. Sorry, my paper. Is that positive or negative? Positive because it's going up. So now we have to find tangent, which is y over x. Is that going to be a positive or negative answer? Tangent in the second quadrant. Negative. 2 radical 6 over 5. Last one. Cover up cosecant. We're looking at cotangent, inverse, 4. Cotangent is x over y. That means we share the restrictions with x. 0 to pi. So cotangent 4, that's the first quadrant. There's my theta. Cotangent 4 has got to be 4 over 1. I'm not drawing scale. I have to find cosecant. And cosecant is y, nope, r over y. R over y. So I have to do my radius. Pythagorean theorem. Square root of 17. Cosecant. This is why we use pencil. Cosecant of whatever theta we just got for that answer. Cosecant is r over y, so that's going to be square root of 17. So we have a worksheet for our assignment, and it says worksheet number 1. However, I am handing out worksheet number 2 and number 3 at the same time. Those are not due next class, but if you wanted to work ahead, you could. But I would make sure that you know what you're doing on worksheet 1 before you do 3 worksheets in a row wrong. I'm just handing them out together because I printed them already.